Welcome to your Day 1 Orientation Explainer for the Clinic Book Engineering team. I am absolutely thrilled to have you on board. Today, we're going to unpack the complete architecture of our robust multi-tenant healthcare platform. Think of this as your developer's blueprint. We are building a massive system here, one that combines the booking power of Practo, the engineering quality of Stripe, and the seamless user experience of Airbnb. We've got a ton of ground to cover, so grab your coffee, get settled, and let's get building.
Okay. Let's take a quick look at the roadmap. We'll start with our macro multi-tenant vision. Go over the directory structure, secure the node server, map our Mongoose relationships, talk React, Tailwind, and Zustand, and finally, look at the real-time sockets.
All right, Section 1, 5 portals, 1 codebase. First up, we're tackling the what and the why of our overarching multi-tenant platform architecture. Before you write a single line of code, you really need to understand the sheer scale of what we're operating. We aren't just building one simple website, no way. We're actually building 5 completely separate user experiences baked into a single application. We've got a public marketing site for SEO, a patient web app for booking, a clinic owner portal to manage entire practices, a doctor portal for daily schedules, and a highly secured super admin panel to control the whole shebang. Every single button you see on this platform does something real.
Now you might be wondering, why don't we use micro front ends or splintered repositories for all these portals? Well, keeping these 5 distinct experiences in one shared codebase is a total game changer. It ensures unified routing, centralized security, and completely prevents mismatched UI components. It means our patient portal and doctor portal speak the exact same language using the same data models. This vastly simplifies local testing. When you're pulling down a branch and reviewing pull requests using our standard Git flow, you can boot up all 5 environments locally to ensure your updates don't break shared components across the different portals.
Moving right along to Section 2, Directory Structure and Setup. Now that we know what we're building, let's map out where your code will actually live. We're building this explainer from absolute zero. Our setup sequence is super straightforward. It starts with a single root folder. Inside, we branch into 2 distinct subfolders, client and server. You'll run your npm init in the server to grab backend packages like Express, Mongoose, and Socket.io, and then initialize a Vite React app over in the client folder. Having them side by side like this streamlines local environment variables and keeps our full stack context really tight. Think of our directory structure as a highly organized filing cabinet. Everything has an obvious, predictable home. The client side cleanly separates reusable UI components and layouts from our global state hooks. Meanwhile, the server neatly isolates route controllers from our Mongoose models and security middleware. So when you pick up a ticket, you'll intuitively know exactly where to look.
All right, Section 3, Node Server and Security. Let's look at the backend constraints and see how our Node Server acts as the ultimate traffic cop.
Your server.js file is the absolute heart of the backend, and it executes in a very strict order of operations. First, it loads our environment variables, then it initializes Express, connects to our MongoDB Atlas cluster, and hooks into our Redis cache for scalable production performance. Only after those external services are locked in do we apply our vital security middleware, finishing up with global error handling. And hey, if any of these phases fail during your initial local setup, make sure you check the debug logs in your terminal. They capture granular initialization errors that will save you hours of troubleshooting.
Now here's a really crucial part of the architecture, database security. Because MongoDB operates on JSON, malicious users can try to inject operators right into our endpoints. By standardizing input sanitization with Express Mongo Sanitize, we strip out prohibited characters and literally stop NoSQL injection attacks cold before data ever hits the database. We also pair that with HPP to prevent HTTP parameter pollution. Basically, security at scale is non-negotiable for us.
To put that security into perspective with a hard number, we enforce strict rate limiting globally. We cap traffic at exactly 200 requests per 15 minutes per IP address. We also rely on Redis-backed rate limiters specifically for OTP requests to prevent SMS bombing. This guarantees our production stability and ensures bad actors can't overwhelm the system.
Okay, Section 4, Mongoose Models and Relationships. With Express locked down, let's dive into our Mongoose schemas.
You really need to understand the relationship constraints here because they dictate how all our data flows. The clinic owner model is a heavy, top-level schema, managing multiple clinics, admin approvals, and bcrypt password hashing. On the flip side, the appointment model is a highly active junction. It acts like glue, tightly binding a specific patient ID, doctor ID, and clinic ID together, while tracking everything from the live consultation status to razor pay billing.
Beyond appointments, our schema isolates multi-tenant data brilliantly. Our user model handles patient health profiles and lifetime bookings for loyalty tiers. The doctor model is heavily focused on working schedules and instant video consults. And the clinic model? It handles specialized 2D sphere geolocation data so patients can accurately query nearby facilities. Every model is highly specialized to serve its specific user portal.
Let's pivot slightly for Section 5, React, Tailwind, and Zustand. Time to look at the front-end paradigm.
Since we're running 5 portals in one React application, our front-end relies heavily on a shared, centralized UI library. We use Tailwind CSS to strictly enforce standardized theme configurations, like our signature clinic teal, across every single page. We also use Framer Motion for smooth shimmer skeleton loaders. But the real magic happens with our layout wrappers. Depending on who logs in, React dynamically wraps the content in a specific UI shell, say a patient layout with a bottom nav versus a clinic owner layout with a heavy desktop sidebar.
So what about the front-end's short-term memory? For global state management, we use the Zustand store. Instead of complex prop drilling or dealing with heavy Redux boilerplate, Zustand seamlessly and lightly manages our global state. It tracks our API authentication status, the current user's profile data, and even our global UI dark and light theming right across the entire application tree.
And here is an absolutely critical secure authentication practice for you. We strictly do not persist access tokens to local storage. Instead, we keep them securely in memory via that Zustand store. To make API calls painless, we use Axios interceptors. They automatically read that secure auth token from Zustand and silently attach it to the header of every outbound backend call. It's clean, it's secure, and it's entirely automated.
Almost there. Section 6, Real-Time Sockets and Flow. Let's tie the front-end and back-end together by mapping out our real-time data flow.
Let's trace a typical request lifecycle to see how data flows between services. A patient clicks Book in React. Axios instantly sends an authenticated API call to Express. Our Node controller processes it, and Mongoose saves the data. But we don't stop there. The backend immediately emits a socket.io event, allowing the React frontend on the clinic's dashboard to instantly update the live queue. Boom, 0-page refreshes required.
Now, obviously, broadcasting socket events to everyone is a massive security risk. By isolating our socket.io communication channels into specific user ID rooms upon connection, we guarantee that highly sensitive data, like check-in updates or chat messages, only flows to the properly authorized portal. It's blazing fast real-time performance locked inside a secure tunnel. Well, there you have it. You've explored the entire directory structure. You understand our back-end Mongoose schemas, our strict security middleware, our React state management, and the real-time socket architecture that makes it all tick. Once your local code is tested and pushed, our automated CI/CD deployment pipelines will seamlessly handle shipping your work to production using your configured production environment variables. You've got the blueprint, the repositories are set, so my final question for you on your very first day is, are you ready to build? Welcome to the team.